Hi, friends, my dear students. Now we are going to see the Einstein explanation of photoelectric equations. Einstein explanation regarding photo photoelectric equation. Yes, as per Einstein theory of explanation, we already seen. I already last class I already explained what he gave the valuable result of a quantum particle and favored to the Planck's. Now, Einstein proved experimentally photoelectric effect was also on the basis of quantum particle theory. For that, he has to consider metal as like shown in the figure. Now, let us imagine one metal that may be considered as a free electron inside the metal enormously. Let us assume one electron inside the metal. In case the instant ray of light rays or any electromagnetic waves, whenever hit the surface with the energy of h nu. Here h is a Planck constant, nu is the frequency of this the beam of this rays, or it may be also equivalent to E equal to h nu. This is the instant ray energy. Whenever hit the electrons, then naturally this electron absorbs all the energy, yes, all the energy of h nu by this electron. Here, now this absorbed energy of the electron from the instant rays are utilized in two ways. One is it carries some amount of energy, it absorbs some amount of energy to break the surface barrier, or unless we can say work function, so that this electron come outside. Okay, that is called one portion of the energy are utilized to come out the electron from the metal. The remaining amount which are utilized for this electron having maximum kinetic energy of the electron. So that if you are adding these two, that is equal to the instant ray energy. That's a detailed explanation of this experimental. Now we can write as per this experiment, the E or h nu of the instant ray energy is equal to the work function that needed to this electron to come out from the metal, and remaining is the kinetic energy of this electron. So that we can write the equation for kinetic energy equal to of mv square. This is the equation that he gave, h nu equal to pi naught plus of mv square. Okay. In other words, in some for example, let us assume the same metal like this. Here, the electron are inside the metal, but only one difference: the heating energy are differed. If suppose instead of nu, instead of nu, we are considered as h nu naught. Nu naught means threshold frequency. If the amount of energy equivalent to the h nu naught, this is equal to pi naught, work function amount, work function that's needed for electron to break this surface barrier or to come out outer surface. That's all. So the total energy of the incident ray h nu naught are completely absorbed by the electron, even though it all energy are exhausted to come out from the metal. That's all. So there is the kinetic energy of, in this case, the kinetic energy of the electron equal to 0, because the incident frequency as the incident ray frequency whenever equivalent to nu naught, then the energy of h nu naught is very less, so that the total energy of the incident ray are completely exhausted or utilized by the electron to come out from this metal, so that the kinetic energy equal to 0. Here now the equation we can modify h nu naught, the incident ray energy are totally equal to pi naught and plus kinetic energy equal to 0. This is the equation 1. This is the equation number 2. Now you can understand here by means of 1 and 2, the h nu naught, it is nothing but the work function. If you are substituting this equation 2 in 1, then we get h nu that is equal to h nu naught plus of m v square, of m v square. This is the equation that explains the total amount of incident ray energy are utilized for work function plus kinetic energy maximum or kinetic energy of electron. This is the famous equation. And it was called as Einstein's photoelectric equation. This is called Einstein photoelectric equation. Now, I think you may understood the clearly, so that I need not necessary to repeat once again. Okay. Now, how can we explain explain the maximum kinetic energy? Maximum kinetic energy is nothing but K maximum equal to K maximum, kinetic energy maximum, that's equal to of m v square maximum, I hope you may understand. If the electron does not lose energy by internal collision between these electron inside the metal, then all the absorbed energy are emitted by means of maximum kinetic energy, so that K maximum equal to K maximum, that is equal to of m v square maximum. Now, where v maximum is the velocity of the electron, Now, substituting the value of K maximum in the equation, then we can obtain some other equation, but not necessary here, because here we want to get two results. One is the total energy absorbed is equal to the work function plus kinetic energy. When it reaches the maximum energy, the maximum energy is nothing but K maximum is equal to half mv square. This is not nu but v. V means velocity. Velocity maximum square. Okay. Now we have to make a graph between E maximum as well as the frequency of the ray. Incident ray K maximum in the y axis. You have to consider a graph like this. Then this y axis called K maximum. K maximum in x axis, let us consider frequency. 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 So we already studied about the threshold frequency. Threshold frequency. With in less than the threshold frequency, there is no emission of electron. We already studied by suitable experiments we have seen already. So this is called nu naught. When the instant ray frequency is greater than nu naught, then only we are receiving, or it may be possible to the ejection of the electron from the metal. That's why less than this frequency there is no emission of electron. So now if you are increasing the frequency of instant ray above the threshold frequency, what will be happen? The electron may be ejected. So if you draw a graph, when you increase the frequency, the kinetic energy also increases, so that the line should be like straight line manner like this. Are you clear? Now, if you are extending this graph, then this is called y dash. Y dash. This is called 0. If you are extending this straight line like this, and it may be intersect the y axis at minus pi naught. At minus pi naught. Now you have to consider at a frequency of nu, there may be a corresponding K maximum is also like this. Okay. Or you have to draw the graph exactly like this point. Okay. Now I want to explain two concepts here. When the incident ray frequency equivalent to pi naught, then the amount of work done by the incident ray are equivalent to pi naught, and that is called, this is called height h, and nu naught means h nu naught. So this energy is called h nu naught. This is the energy which are absorbed when we are applying the incident ray with the h nu naught. Then what happened here? The amount fully received by the electrons are completely exhausted to the work function itself. Okay. The second one, here you have to consider the value of this level. You have to consider this like this. This is called h nu. This is called h nu. So you have to consider this value. This is called, this amount of energy is converted to be as a kinetic energy of the electron, and this amount of energy is equal to the work function that needed to bring this electron inside the metal to come outside. So that's why the total energy of h nu is equivalent to pi naught plus kinetic energy. So as per the equation we already wrote, h nu, that is equal pi naught plus kinetic energy of the electron of m v square. If you are substituting this pi naught value, then that's equal to h nu naught. H nu naught plus of mv square. Are you clear? Okay. Now, I want to find out the value of mv square, or this is called k maximum. K maximum, this is called also maximum. So I want to find the k maximum value. Then you have to take this value to that side, that we get m m v square maximum is equal to h nu minus h nu naught, or you can write h nu minus pi naught. This is the energy equivalent to the work done. Are you clear? Are you clear? This is equation number 3. We already obtained two equation. This is called 3. So from this graph, he Einstein concluded that all the kinetic energy, whenever the electrons having this amount of instant ray energy to completely absorbed and evacuated, and emitted in kinds of two way. One is work function, another is kinetic energy of the electron. And this equation shows that maximum one famous value for us, gives one famous value. Kinetic energy of the electron equivalent to total energy minus pi naught. That's all. This is the total energy of the instant ray. This amount of energy is needed to the work function. Remaining, the difference between these two, instant ray energy and work function energy, that amount is called K maximum. This is called K maximum. This is an equation for, so finally we get the equation K maximum equal to of m v square maximum, of m v square. Therefore we can write K maximum is nothing but of m v square maximum. This equation is obtained by the Einstein, and very important equation to explain the photoelectric equations. Now, after Einstein, R.A. Millikan, another scientist, after Millikan, now I have to remove all these things. I hope you may understand the concept clearly. Einstein theory of explanation of photoelectric equation. Now we have to explain another concept. Mr. R. A. Millikan. Millikan's experiments. Millikan experiments. He considered more number of metals and draw a graph. We already draw like this. K maximum in y-axis. K maximum that is kinetic energy of the electron. K maximum is considered to be in the y-axis, and frequency in the x-axis. Then what we already told, there is a threshold frequency, then this is called a straight line. Likewise, he consider metals like lithium, cesium. He consider metal like cesium, Cs, potassium, and sodium and and calcium. He considered for his experiment four kinds of metals. Here, the slope of all metals, the slope of all metals are not changed. Likewise, each and every line as shown in the figure. This is called y dash axis. Here, wherever you want to find the slope value all are equal, and the work function amount minus pi naught value varies metal to metal. For example, Cs, we already studied in theoretically minus 2.14 for cesium, and for sodium, potassium, sorry, sod, calcium, cesium, and sodium. This is called potassium. Sorry. For the work function of the cesium is called 2.14, and the work function of the potassium is called 2.30. We already studied in the initially in this chapter, and this one is minus 2.75, and the last one is minus 3.20. This is a work function needed for this cesium, potassium, sodium, and calcium. Here, one important concept that you have to understand: the slope of these all metals are the same. From this graph, we conclude that there is no change in the slope, means it is a slope just like Einstein derived slope, both are equal, but the work function may be differed, so that he conclude that R.A. Millikan concluded the theoretical value as well as the tabulated value are very closer and very equivalent, so the Einstein theory of photoelectric equation was proved. Here minus 2.14 volt, this is called electron volt, or it may be explained, this is called this amount is called voltage given by the voltage, or electron volt. Therefore we can write EV. This is a RA Millikan experiment prove that there is no change in the slope. So according to Einstein principle, we derived an expression for photoelectric equation is absolutely accepted by a proof of R.A. Millikan. This is a very interesting question, how Einstein was succeed to explain the photoelectric equation. I hope you understand in the question in the happiest manner and clearly the concept explained by this experiment. Thank you, friends. If you need my class, try to subscribe my channel and click the all bell. Thank you. Thank you, my friends.